Everyone. Just set this camera right. Sorry, it's a little bit. There you go. Okay, see the board? I'll just get onto this on my phone so I can see people's comments. So, videos. Macam Guy is live. Haloalkanes Questions. There we go. Right. Okay. So just before I start, for the benefit of anybody watching this after it's gone live to my students, the link to the questions is in the description. So if you wanted to download the link, download the questions, have a go at them, and then obviously you can sort of, the video will make a lot more sense. Okay. Right, so we'll get started. It's 1 o'clock on Monday. So the first question was asking about polarity of bonds. So first question said, explain why the CCl bond is polar, whereas the CH bond is not. So it's all about difference in electronegativity. So you've got the CCl bond versus the CH bond. So in both of the bonds, you have got different atoms. In the CH bond, the difference is only very, very small, okay? So difference is very small, and by that I mean difference in electronegativity. So the difference in electronegativity is very small, therefore the bond is non-polar. And at A level, apart from bonds like ClCl, where you've got the same atom, that's obviously non-polar, the CH bond is the only bond with different atoms in that you would class as non-polar. Okay? So CH bond is non-polar due to the very small difference in electronegativity. And then if we jump over to the CCl bond, the difference is large. So difference in, I'll just put En to speed things up. The difference in electronegativity is large or larger. Therefore, it's polar. Oops. So that's the kind of thing you would need to say to get all the 2 marks for that question, okay? You must make a comparison. So you can't just talk about one thing, you've got to talk about both and sort of compare them, okay? So that was question 1. So my students, if you're watching this live, please feel free to ask any questions. I can't see any questions popping up on the screen at the moment, so I'll just crack on. But if you do want to clarify anything, then just fire the questions and hopefully I'll see them and get them answered before we move on to the next question. Right, question 2. I'll just get this up on my phone. Show the mechanism for the hydrolysis reaction of chloroethane and sodium hydroxide. Show any relevant dipoles and electron pairs and give the name for the mechanism. So show the mechanism. Okay, so chloroethane, we'll do displayed formula. You can do it with skeletal, but it's better with displayed. So, okay, so there's your chloroethane. And the first thing I'm going to do is I'm going to show the dipole across the CCl bond. But we've just said this bond's polar in question 1. That's the more electronegative one. It's pulling the electron pair in that bond towards the chlorine. So I'll just rub that out. So that's going to be slightly negative, making that carbon slightly positive. So we're hydrolyzing this with sodium hydroxide, but for the mechanism, we only need to include the hydroxide ion, okay? So I'm going to show, don't forget that minus sign. When I was marking the homeworks, I noticed some students were missing out the minus sign. And I'm sure that was just an oversight, okay? Well, it wasn't that you didn't know it needed to be there. I think it just maybe just forgot to put it in. But obviously that's going to cost a mark. I'm going to show a lone pair on the oxygen. So the rule for the curly arrow is it has to go from either a lone pair, and this is for OCRA, which is what we do. It's got to go from a lone pair or a minus sign. You can't do your curly arrow from wherever you want. That wouldn't get you any marks, okay? Because it's not coming from any of the specified places. So I'll just rub that out. It's wrong. Okay, so let's take it from the lone pair. So we need to draw a curly arrow going from the lone pair to the slightly positive carbon. And what that's going to do is it's going to repel the electron pair that's already tending towards that chlorine. It's going to repel them completely onto the chlorine. So take your curly arrow, ideally from the middle of the bond, and shove it onto the chlorine. And effectively that's going to break that bond by heterolytic fission, okay? So if there was more marks going for the mechanism, and it might say state the type of bond fission that's occurring in the mechanism, you would need to include that. But this wasn't worth enough marks, but we'll put it on just for a reminder. Heterolytic fission of the CCl bond, okay? So all that's going to do, nice simple mechanism, it's going to create, so that doesn't change obviously, there's nothing happening on this part of the molecule. So that's a covalent bond now from the oxygen to the carbon. And obviously there's a hydrogen. I'll show a full display for that, but I'm sure you could get away with just OH. Okay, and the chlorine is now an ion, Cl minus. Okay, so that's the mechanism. And the name for the mechanism, we had to give the name, was nucleophilic. Now be careful, there's only one L in that part of the word, and when I'm marking homeworks, a common mistake is a double L there. So nucleophilic substitution. Okay, so that was that question there. So in terms of marks, you're probably looking at 1 mark for that curly arrow there, another mark for the dipole and that arrow there, that curly arrow there, and then the third mark will say for the correct products and the correct name of the mechanism spelled correctly. Okay, just triple checking I've spelled that right, because that would be really embarrassing if I'd spell that wrong on YouTube. Nucleophilic, yeah, that's right. Okay, so that was question 2. So any questions? Any questions for the 10 people in the room at the moment? Please speak now. If not, I will rub the board. Don't really want to rub the board if there's a question. No, it's pretty quiet, so let's rub this out. Okay, so question number 3. Okay, so now I'm showing my age here, but I don't know what that means. So that's probably quite embarrassing to admit to, but I don't know what that means in modern sort of speak. Anyway, okay. Right, place the following, question 3, place the following haloalkanes in increasing order of their rates of hydrolysis, increasing order of their rates. So obviously we're starting with the slowest. Oh, they're agreeing with what's above, thanks. I missed what's above. Ah, right, okay. Rebecca said, do you need to show the lone pairs on the Cl minus? Right, good question. Okay, so, sorry, the mechanism's gone now. So the Cl minus that's generated after the heterolytic fission's taking place, you don't need to show a lone pair on that, but sometimes you do see it, so either is fine, okay? Cl minus without the lone pair or with the lone pair, that's absolutely fine, okay? But what isn't fine is drawing a curly arrow from somewhere other than a lone pair or a minus sign. That's where you lose marks. Okay, so place the following haloalkanes in increasing order of their rates of hydrolysis. You need to be really clear. So when I was marking, or when I mark homeworks on this type of question, sometimes students aren't clear. I know that you know the answer, but if you're not clear enough to the person marking your work, at the end of the day, an examiner, a random examiner, they're not going to give you that mark. So you need to be crystal clear in your answer. So, increasing order of rates of hydrolysis. So we need, why don't we have, oops, that's not a very good start, slowest, and then fastest. Okay, so we're in no doubt now. So the slowest one was the chloroethane. So we'll just use skeletal formula for speed. Chloroethane is the slowest. Then you've got the bromoethane, and the fastest one is the iodoethane. Okay, so that's nice and clear. Slowest, intermediate, fastest hydrolysis, or highest rate of hydrolysis. Explain your choice of order. Okay, so it's all about the strength of the carbon-halogen bond. Okay, so the rate of hydrolysis depends on the strength, or you could say the bond enthalpy of the carbon-halogen bond. So that's the slowest one because the CCl bond is the strongest or has the highest bond enthalpy. So strongest, and the Ci bond is the weakest or has the lowest bond enthalpy. Okay, you don't really need to mention the CBr bond because it's obviously going to be in between. If that's the strongest and that's the weakest, it's obvious that CBr is in between. Okay, so clearly we've clearly shown the order, and we've clearly explained that rate of hydrolysis depends on the strength or the bond enthalpy of the carbon-halogen bond. CCl is the strongest or has the highest bond enthalpy. Ci is the weakest or has the lowest bond enthalpy. Okay, so that was that one. Any questions on that? And I will keep my eyes peeled so I don't miss anything. Great album, Kraftwerk's Autobahn. I would thoroughly recommend it if you're into that sort of thing. Especially this track. 22 minutes long, it's fab. No, nothing, okay. All right then, number 4, methanol reacts with, so we're given some, this is not a reaction that's required on our syllabus, okay? So this is an example of where they're giving you some information and you're having to process it and try and apply what you do know to something that you've never seen before. So methanol reacts with sodium, can act as a nucleophile. So you're told that. So we know from the question that this CH3O minus ion is a nucleophile. Okay, so part A, explain why the methoxide ion can act as a nucleophile. So what I would recommend is always try and get the definition into your answer, okay? So a nucleophile is an electron pair donor. Okay, so a nucleophile is an electron pair donor. We've just seen in the mechanism in question number 2, the one that is on the syllabus, the hydroxide ion mechanism. So we saw the OH minus ion donating a pair of electrons. You see I've taken the curly arrow from the minus sign this time. Okay, and that's gone. Okay, so all we've got to do is apply it to this. So surely the methoxide ion must be able to do the same thing. And it was, very, very similar. We know that one. We're told about this one in the question. It's got to be doing the same thing. So how I would answer that question is the methoxide ion has a pair of electrons on the O minus, which it can donate to a slightly positive carbon or an electron deficient carbon. Okay, so CH3O minus has an electron pair which it can donate. So there's the definition in there, electron pair donor to an electron deficient carbon. So that would get you absolutely no question, that would score you all the marks. Okay. And then the final, or the second part of the question, show the mechanism for the reaction between 2-bromopropane and the methoxide ion. Include relevant dipoles, curly arrows, and clearly show the structure of your organic product. Okay, right. So 2-bromopropane. Keep forgetting this is magnetic. 2-bromopropane. 1, 2, 3. Br on carbon number 2. Hydrogens around here. Methoxide ion, let's put it sort of there, O minus CH3, delta plus on the carbon, delta minus on the bromine. So what's going to happen, let's go for the curly arrow from the minus sign this time, just so you see in both types of mechanism. So from the minus sign, curly arrow to the carbon, and then that's going to break that bond by heterolytic fission again. So it's going to repel the electron pair in the bond, so it's going to start in the middle of the bond up to the bromine, like that. So what will that generate? So nothing on the ends of that's not changing, is it? H, 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 H. So because I've got the methoxide ion going in that way, that H doesn't come off, does it? So let's just put it up here. So remember, these bonds can spin round because they're sigma bonds, okay, they can rotate. So showing clearly the structure of the product. So the O's bonded to the carbon, and then what's bonded to the O is the CH3 group. So let's fully display that out. And that's it there. And then that bromine, don't forget about that. Br minus, with or without the lone pair. So I've put it on there just so you've seen both types. Okay, so that would be that one. Okay, right, so number 5 now. So we're moving into the environmental aspect of the topic, haloalkanes. Right, okay, so number 5, explain why ozone depletion should be of major concern to humans. 1 mark. Okay, so ozone absorbs harmful UV radiation. And then you could say, well, why is UV radiation harmful to humans? UV causes skin cancer. or you could go into more detail and genetic damage to cells, or you could just say UV causes skin cancer. Okay, so you're clearly saying what ozone does. UV causes skin cancer. So ozone depletion, or less ozone, means less UV absorbed, therefore more reaches Earth. Right. That's a lot for 1 mark. It's probably writing too much there. But ozone. So what does ozone do? Why is UV bad? What does ozone depletion mean? I would say for that one. And then the final question, question 6. Write equations to show how the hydrochlorofluorocarbon. So it was HCCl2F. How does that break down ozone? So this is a different, normally in sort of textbooks and notes and what have you, you would have CFCs, which just has carbon, fluorine and chlorine in. I've put in the questions a hydrochlorofluorocarbon, which is it's got hydrogen in, obviously, from the name. So HCCl2F, HCCl2F. So we'll just go for like a displayed formula. So how does it break down ozone in the upper atmosphere? Use your equations to write the overall reaction for the process. Right, so UV, now because the CCl bond is weaker, it breaks. So let's put the pair of electrons in and let's split that bond, and that's homolytic fission. Okay, so that's going to generate a chlorine radical. So this one here, so notice that electron there is going to be kept by that chlorine. And then this thing here has got the other electron, so that's a radical as well. So that's HCClF dot to show that it's a radical. Okay. This thing here is the nasty thing. Okay. So if we bring ozone into play now, and just for more like kind of revision purposes really, this is an initiation reaction. Just if more marks are up for grabs, they might want to know what kind of steps they are. So initiation, because you've formed 2 free radicals. Okay, right. So what's going to happen? Ozone is going to be attacked by this chlorine radical, and it's going to form a ClO radical. So this is a propagation step. Propagation. So remember, these always occur in pairs, so we've got 2 of them. So let's just code this as P1. So therefore the other P2 step, this new radical that's formed, ClO dot, reacts with an oxygen atom, which is also in the atmosphere, and that's going to generate a chlorine radical and another O2 molecule. So you can see that when the overall reaction is the sum of these 2, so basically we just add these 2 equations together. So you can see that we're going to have that plus that plus that plus that gives that plus that plus that plus that. And hopefully you can see that the ClO radicals will cancel and the Cl dots will also cancel. And so therefore, what's the overall the upshot of all of this? O3 is combining with an O atom in the atmosphere, and it's forming 2 O2 molecules. And the bad thing about this is it's not reversible, and basically the ozone is being broken down. So ozone broken down. Now sometimes they'll ask you, oh, so is there no termination step? No, Abby, not for this. This would be what you would write for a question like that. A classic question about how do these radicals break down ozone. Okay, obviously things will terminate, okay, but not like, you know, the radical substitution mechanism where you do need to include termination steps. That's not required in here, okay. But if they said suggest a termination step, they could do that. You just take any two radicals and join them together and form the molecule. Okay, so the easiest one to do would be for a termination step. If you really wanted to see one, you could say two Cl radicals would form Cl2. But in 20, 26, 27 years, I don't think I've ever seen that question asked as part of this type of question. Okay, but I'll just put that in a bracket. The other thing I wanted to mention on this, and it wasn't part of the question, but they sometimes ask it, is state the role of the chlorine radical in the mechanism. Okay, so let's focus on these chlorine radicals. So you can see in the first propagation step it's being used up, but in the second propagation step it's being regenerated, reformed, and so therefore the chlorine radical is acting as a catalyst. So Cl dot, where can I put that? Just put it up here. Cl dot acting or acts as a catalyst. And that is that. So how long's that taken? That's not taken very long, 26 minutes. So any final questions? I guess people who are watching this, because I'm going to make this public after your lesson. So anybody still watching this who's not one of my students probably won't want to listen to this. But any questions from people, my students, anything that I haven't mentioned clearly enough? All good? All good. I'm taking that as a yes, it's all good. I'll just go on to this. Okay. How are we meant to know which atom on the ion has a lone pair / negative charge? Previous question. So that was. So you're talking about the methoxide. Are you talking about the question 4? Adam, I'm guessing it's question 4 because there was no ions involved in question 5. Yeah, right. So I think what you've got to kind of use your knowledge from what you do know. Okay, so you know hopefully that an O- ion. Let me just rub the board. So OH minus. So you've effectively got a pair. Let's draw this out fully. Right, so we've got oxygens in group 6, okay? So 1, 2, 3, 4, 5, 6, but it's negatively charged, so it's got an extra electron, okay? So using a different symbol, that would be like a dot and cross diagram for a hydroxide ion, okay? So technically, there's 3 lone pairs around that O-, and any one of those would be attracted to the carbon delta plus, okay? So you kind of know that from what you've been taught, hopefully, all right? So in that question, they've asked you about this, or they've told you about this new ion, okay? all I would suggest is make sure you can see there's a massive similarity between that and that. So obviously if we were to draw all of this out, you've got dot cross, dot cross, dot cross, and then let's go dot, 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 triangle, minus sign. So that would be what C delta plus. Okay, so you're not expected to know all of this stuff off by heart, but you kind of are expected to work it out from what you do know. So you do know that, hopefully. Can you link it to that? Have I answered your question? It's difficult, I can't hear you. So I've got to wait for your answer to come in. It's just this awkward sign. Yeah, I understand. Brilliant. Okay, cool. Any other questions before I explain what we're going to do or what's happening later on? Well, I'll start talking now, and then if anybody's got a question, obviously just put in with your question and I'll see it pop up on the screen. Right, so I don't know if you noticed on Google Classroom, I've posted an announcement to say that there's going to be a public live lesson on Wednesday at 7. Okay, so you're more than welcome to attend, but what I'm wanting to do is go through like an entire topic with whoever wants to attend. So it's not just locked for you guys, it's anybody can attend that one, and it's at 7 o'clock at night, so it's out of my teaching hours. So if you want to attend, you can. If you don't, or you can't make it, that's absolutely fine. Obviously, if you're not in the room at the time it's being done, you can't ask questions. But you guys can always message me on Classroom if you need any help with anything, or email me, whatever. Okay? So you're not really at a disadvantage for it being public. I've also this morning set the work for this week. So this week's topic is synthetic routes, organic synthesis. So I've posted some videos to watch, I've posted the notes, I've posted the study packs, I've posted the answers to the study packs, and I've posted the completed notes. So everything for the topic you've got, okay? And over the next couple of days, I'll try and do it this afternoon if I can. I will write some questions like the ones we've done today, which will be my sort of mark, the stuff that you must send back to me, and I will mark, okay? So thanks everybody for handing in their homework on time. I had to nudge a couple of people, I won't name them obviously, but hopefully they will get back to me with their homework, otherwise you have to go on the naughty list, all right? And somebody higher up than me will be getting in touch with you, so don't put yourself in that position. What else was I going to say? Oh, I'm going to be on Radio Tees this afternoon, sometime between 4 and 6, talking about you lot and what we're doing to get through this. So if you want to have a listen, then I don't know what time it's going to be on. So if I get word when it's going to be, I will let you know, and you can listen to it if you want. So that's it really. So next Monday I'll do a lesson like this one where I'm going through the answers to the questions. So you'll be handing in your answers to this week's topic on Friday, I guess, and I'll mark them over the weekend, get them back to you, and we'll talk about them on Monday at 1 o'clock. Okay, so that's the plan, and I think that's how that's going to work from now on. So does that sound okay? Silence. Sounds good. Thank you, Reese. Okay, great. Reese, please pass on my best wishes to you know who I teach in year 13. You know who I mean, don't you? Please pass on my best wishes. Hope everything's going okay with that lot. Okay, because I still do think about them. Great. Okay, fine. Everyone's saying yeah, sounds good. So that's what we're doing. But please don't be shy getting in touch if you're stuck on anything. And that's it. So bye-bye. I'm going to have some lunch now. So I will see you maybe on Wednesday, or you'll see me on Wednesday if you join in, 7 o'clock. Otherwise, I'll see you next Monday at 1 for the answers to the questions that I'm going to post this afternoon once I've written them. Bye. So wait to see if anyone says bye. Does anyone say bye, or they just hung up? Still 10 people on. I think there must be a delay. It's a slight delay, unless they just, oh, a like? No way. Bye, Rebecca. Bye, Georgina. Bye, Luke. Bye, Catherine. Hope you've all subscribed, by the way. God, can you imagine? Nobody 2 likes. Somebody's gone. 2 likes. Thanks for whoever that was. I can't. It's going down now. Right, I'm going. See you later. Bye. See you, Abby. Take care. Bye. How do I end? Oh, yeah.